Hey, so let's create an interpolator for my old commute. Let train journey equals d3.interpolate 0 at Stockholm, 69 kilometers at Uppsala. So what d3.interpolate does here is that it takes parameters a plus b, 0 and 69 here, and it creates and returns an interpolator function that interpolates between a and b. We can then use this interpolator to generate the midpoint of the journey, like this. We're letting midpoint be the result of calling train journey with 50%, and then we're displaying that value and we see 34.5. When I'm coding this out, I'm using observable framework. You can download this project in the episode description actually to play around with it yourself. It's a really good way of getting a D3 playground. You just npm install and boom boom. So the closer the argument is to 1, the closer we are to 100% of the journey. So if I change it to 0.99, the displayed value changes to 68.31, and if I change it to 1 or 100% of the journey, it returns a full distance of 69, that is, 69 kilometers. So you're probably getting how this works now. At 25% of the journey, we are at 17.25. So I broke that out into a t variable there, and you might be wondering why. After working with these examples for a while, I started wondering what word to use when referring to this number you give to the interpolation function. What is the name of this argument here? Because I want a fake competence when I'm talking about these things in these videos. And it's t, literally. T. it's just T. So if you're a programmer or another type of sane person, you might wonder what T is short for, but T isn't short for anything. This is just something you have to accept, that mathematicians, they are feral. Mathematicians, they don't name things. They just glimpse into the Platonic essence of it and they assign a letter. Why debase yourself with descriptive names when you can just use T and feel the raw power of abstraction? ASCII will not hold us. So, remember that the reason that we are exploring all of this in the first place is because we were not completely unconfused about this particular sentence in the documentation for D3 scale time. Constructs a new time scale with the specified domain and range, the default interpolator, and blah blah blah. So this means that scale time per default uses this, the default interpolator behind the scenes. And if we look at the definition of d3.scaleLinear, the definition of that is almost exactly the same. Constructs a new linear scale with a specified domain and range, the default interpolator, and blah blah blah. So I'm not a D3 expert, I only play one on the internet, so I'm probably wrong and oversimplifying, but right now it helps me to think of scaling functions as interpolators with more bells and whistles. So for example, since we now know that scaleLinear uses d3.interpolate under the hood, unless you tell it otherwise, I guess, we can do something like this to get the same behavior from a scale. We're letting Stockholm to Uppsala be a scale with range from 0 to 69, and then we let a midpoint from that scale be a call to the interpolator, or the scale. I mean, they're hard to tell apart, right? With 50%. And that gives us the midpoint from scale, and we display that and gives us 34.5. As you might remember from the last episode, when we don't provide a domain to the scale, the input domain just becomes like from 0 to 1. So that, like, it's sort of like the default is that it goes from 0% to 100%, or like 0 to whole, or I'm not sure what you call it, wholeness. Like it comes back to this Platonic essence in math. But I remember from last episode that we read something earlier in passing about an invert method, which I suppose is one of the additional functionalities that scale adds on top of an interpolator. Again, like scale is kind of like an interpolator with bells and whistles. And because D3 is actually kind of intuitive once you understand the logic of it, I think I can kind of guess what this syntax looks like. You take Stockholm, Uppsala, and we call invert on it, and then we pass that 34.5 the other way around. Shit! I thought that would be like a good kids, you don't need an LLM to code moment. You can just use your intuition, but no. Okay. So the syntax is actually like this. You don't actually need to create a new scale to invert it. I kind of thought that you needed to create like an inverted scale, like by calling an invert, but looks like it's not how it's designed. So as you see here, this allows us to use the scale in the opposite direction. We pass in 34.5 and we get 50% out, as that is the midpoint. So, how are you doing? Are you kinda sorta getting it? Maybe? If you're uncertain, that's good, because in Dirty D3 we're not here to merely get it. We're here to get fingerfärdiga. This is not divide and conquer, it's divide and comfortable. Be kind to yourself. Anything else just leads to shitty code and shitty understanding, and you'll have to do more work later. So, before me and my then girlfriend moved to Uppsala, we initially moved to Upplands Väsby. The logic behind that was that my girlfriend studied in Uppsala, I worked in Stockholm, so living in the middle between those cities would be a sensible compromise. This was actually incredibly dumb, because there was literally nothing to do in Upplands Väsby, so neither of us could have a life. There's like some stone ships in Runsa that you can check out, and then you're out of things. But anyway, I wanted to figure out how far from Stockholm Upplands Väsby is relative to Uppsala, because I suspect that our core motivation to live there, the assumption that Upplands Väsby was halfway to Uppsala, was actually wrong. So I knew that I was dumb, but I want to find out empirically if I was even dumber. First, let's figure out how far Väsby is from Stockholm. Oh shit, the glam metal band is from Upplands Väsby. I found it. The distance to the city center of Stockholm is 25 kilometers. We put that into our Stockholm-Uppsala scale and we invert it, which shows us that Upplands Väsby is actually 36% of the way to Uppsala. So it's not even close to halfway. So even the core assumption underlying our decision to move there was flawed. Alright, so how much commute time did I have there? Travel to Stockholm Central Station takes 27 minutes 10 station by commuter train. Holy shit, my life was so much transport before the pandemic. Let's see if we can interpolate our way to that number. 27 minutes, if we can reach the same conclusion. And I actually remember with my head that the train ride from Uppsala to Stockholm takes 38 minutes. So let's map an input domain of 69 kilometers to an output range of 38 minutes. 13 minutes? The Wikipedia article says that it should be 27 minutes. So did I mess something up here? I'll change the value to the full distance to Stockholm to verify that the scale actually works. And that gives us 38 minutes, the correct values, which seems sensible because I'm so awesome. But it actually seems like the problem is with Upplands Väsby. Let's just do some math on the factual measured trip distances. What do we know? Oh my god. This must be how time slows down near a black hole due to the extremely strong gravitational field of the black hole. But it also applies to Upplands Väsby. Today we learned about the D3 concept, d3.interpolate. To recap, we learned that interpolation is about finding values between known points, whether those points are numbers, colors, or even weirder things. d3.interpolate is D3's clever type inferring function that creates specialized interpolators based on what you give it and serves as a core engine of D3's scales. So before we say goodbye, let's figure out what we'll do next time. Looking at the docs at the point where we started off our rabbit holing, we were here. I believe I previously said that we have a rule that we dive into whatever confuses us when we encounter it, and that was me successfully gaslighting you, because I totally broke that rule here when we encountered d3.interpolate. It would just have been so weird to learn how to interpolate colors before we learn to interpolate numbers. But now that we do know that, if B is a color or a string coercible to a color, use interpolate RGB. I think it's clear that the next episode we're getting our hands dirty with color interpolation. And unless we are diverted, which has been known to happen, we'll finally get some actual visualization in this data visualization series. If you're watching this from the future, you can find that episode here. Or if you need a little break from D3, you can check out this video.